Hey, so we created an artificial intelligence for CS10 at Berkeley in BYOB, and basically what it does is it takes a starting word and produces a final word through a series of manipulations from functions that we created that are similar to the midterm and final. And so basically what it does is it branches out and tries various possibilities by using a combination of different functions. So basically the order of magnitude is the number of functions to the power of the tree branches. So we put a limit on it that basically cuts it off after a certain point, because otherwise the program would take excessively long to run. So let's just run a quick example. We'll have our starting word be bears and our final word be ears bear.
And then the program will ask us to choose which functions here we want to use. Here we are choosing the starting word and the final word. And then we're going to choose an end and double. There you go.
So this will also give you hints.
We'll set the limit of the depth of branches to be 3 for this case, and we'll show what the program is thinking as it goes along. So 2 seconds per function.
And this is the solution. So you can see bears is the starting word here, and then the 2 represents the second function being used, and the 1 represents the output of the second function being used as the input as the first function, which is unend.
So now let's try running it again, but not show what the AI is thinking. It'll hopefully be a lot faster. They're using the exact same functions as we did before. Depth of 3, and this time we'll say no.
It's testing the functions, and there's the result. It took 4 seconds for the program to find the correct result.
And as you can see, it's in functional form as well. And now let's look over at some of our code that we wrote. So it may look a little long at first, but this bottom else bit is actually pretty much the same as the beginning if. Our main AI program is recursive. And as you can see, here's the recursive bit that calls the same function within itself. And so by itself, it does run all of the branches, but as you can see, we did have some pruning algorithms that sort of limit the number of steps that it has to take.
Yeah, so here is the kind of the basic function in work, with only like a couple of pruning algorithms. One being when the word gets down to no letters long, it'll cut it off and skip it.
And so we have a couple different types of pruning algorithms. One you can see here is an external pruning algorithm. So we have a couple of checks that as soon as you enter the words in the functions, it checks to see if it's even a possible solution, and it will let you know if it is or if it isn't. And we also have a couple of pruning algorithms within the recursive step itself, and this will check the functions as it goes along. See internal pruning algorithm. That way it can cut off branches as it goes down into the depth of the tree.
So the pruning algorithm in this recursive function will check to make sure that the starting word has all the letters that the final word has. So this was the initial one without that pruning algorithm we just talked about. And after we added the pruning algorithm, this is the tree that it checked. It skipped all of these because this output is missing the B from bears. So it was allowed to skip all of those. It made it much faster.
And that's it.
That's our program.
Thanks for watching.